Okay, clarifying from yesterday. This is a question about worksheet 2.2 number 1, which we assigned yesterday. And this kind of a problem comes up where you have k of y is equal to ym squared. And I'm guessing before I explained this to you guys, your assumption would have been that which one of these would be the constant? Y, but it is not the constant. What is y? It's the variable, which is also the base, yes. This is the variable. So if this is the variable, that makes this, what? The constant. Even though it's got a squared on it, it's the constant. Now sometimes it'll be lucky, you'll be lucky, and it'll say in the directions that m is a constant. Well, awesome. And they told you that if that's the constant, then that has to be the variable. And then what's the power that we're concerned about? It's not the 2, the 1. That is the power in this power equation. Because that, if it's really a constant, constants are like a number like 7. Well, then it's just 7 squared, which is 49. It doesn't really have a power after all. Get what I'm saying? All right, yes, ma'am. If it didn't have this beginning part, you wouldn't have been able to tell.
So, but in the directions when it says that it's a constant, if it didn't say that, would it still be that?
Because they've told you this, then yes, you would be expected to know, even if it doesn't say in the directions, that this must be the variable. It has to be because of how the problem's set up. And if that's the variable, the other one must be the constant. Okay, one last, yes?
What if it doesn't have that k equals y, but the directions said
It would.
m and l are constant?
Okay, if it didn't have this, and then it said, by the way, m is the constant, then for sure the y has to be the variable. All right, let's do one more like that. M of p is equal to, I'm going to make this a little trickier, r squared, no, p over r, that's going to really be too tricky. R squared over p. Yeah, that's a really tricky one. Okay, I want you to try to figure out, is this a power function? If it is a power function, what is the power? And what's the constant? Write it down. Write down P. You think the power is this, and you think the constant is that. I added a twist in there to make it a little more challenging. I know you got somebody else's paper, but it's pretty much, there's a lot of room on the backside. They won't mind. So there's two things. This stuff's got to be either variable or constant. So I hope you figured out that by saying it this way, that's the variable. If that's the variable, do you remember me making you write these all on one line? M of p is r squared p to the what? -1. So what's the power? -1. And what's the constant?
R squared.
Yep. All right. I hope that helps you understand those a little bit better. All right, now we're going to pause for a moment and go on, grade some homework, and then I'll come back to the video. Okay, here we go. Today we are talking about graphing, and it's really not too bad. Grab a graphing calculator. I'll show you a few that you'll have to know. You're going to be graphing power functions. You basically have to be able to recognize them. So like if you see this graph, you should be able to say, oh, I can tell that's a square root graph. No problem, just leave me a shoe, or a cell phone. And I have them in my backpack this time because this room is going to get used for something else. Anybody else need a calc? If you need one, hurry up, borrow one. Okay. Thank you. So if we graph x squared and x to the 4th, you can tell they're a lot alike. So x to the 6th, x to the 8th, anything that's even, it's going to look generally like that. Okay? Do you recognize x to the 3rd in your head? Do you know what x to the 3rd should look like? Okay, let's go verify that. Go to y equals and make this x to the power of 3, and then get rid of the other one. We just want to graph x to the 3rd. hit zoom 6 and it'll probably fix it. Otherwise, make sure there's no plots on. Okay, so hit graph x to the third. You remember how this looks? Take a guess what happens when you graph x to the fifth. Just like this, except a little skinnier. X to the seventh. Here, trade you. Just for now. Okay, come on up. There's more in here. Okay, so if I asked you to pick off of an amazing conglomeration of graphs like that, 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 that. That's kind of what your homework's going to look like today. One big giant list of a whole bunch of graphs, and it's going to say which one is x to the negative third, that kind of stuff. All right. So, and it would be the green one. Very good. Because first of all, you'd have to say, well, generally, what does x to the third look like? And you have to be able to pull that one up in your head. Say, oh, okay, x to the third generally looks like this. And then when you do a negative to it, it's going to make it flip. And so all of a sudden, you know that the answer has to be like that. But if you don't know what they look like in the first place, you're kind of stuck, right? If you're still struggling with the calculator, come and trade it for one of mine, please. I don't have time to fix your calculator right now. That's not what x to the third looks like? Okay, then you go to zoom 6 and make sure your zoom isn't messed up. Okay, sorry, I can't take time to fix that right now. Okay, so, shh, quiet please. So, I want you to know a few of these, and here's the ones that I would expect you to know. I've written them down for myself. Anything that looks like this, we just summarized it a second ago. Can you give me, what would that be again? X to the second, x to the fourth, x to the sixth. Make a little note to yourself, because if even the teacher had to write them down, you're not going to remember these in the day. Okay, so make a little note. Yeah, that one you'll probably remember, but what about the next 4 or 5? You're just going to start getting lost. You will. And you won't have a calculator to fall back on the test either. All right. So next one. The ones that kind of look like this, and they're just a matter of how stretched they are what again? X to the third, x to the fifth, x to the seventh. How about x to the 1? Isn't it sort of like this in a way? Y equals x to the 1? It's in the same quadrants at least. It's just all straightened out. But x to the 1 is different than x to the third, x to the 5, x to the 7. Okay, so those are some of them. How about this? If I put a negative in front of it, it flips it upside down, right? But what if I do a negative in the power, x to the negative second? And that one looks like this. All of a sudden, it's got asymptotes. Can you remember that x to the negative second is the same as 1 over x to the second? And do you remember those 1 over x ones are the ones that had the asymptotes in them? All right, so that's kind of what they look like. And I'm going to call that a volcano. Sort of look like a volcano? A little bit? Okay. And so then take a wild guess. What other things look like that? X to the negative 4, x to the negative 6, etc. Okay? All right, next ones I'd want you to write down would be the odd negative powers, like x to the negative third. I had to check my notes. How about this? Do you get that this graph here was in quadrants 1 and 2? And when you did the negative of it, it's still in quadrants 1 and 2? Check out the cubed one. The cubed graph, that's in quadrants 1 and 3. And notice it's still in quadrants 1 and 3, except it's got asymptotes. I don't know if you're catching on to any kind of theme. All right. So now let's move on to the 2 more that I kind of want you to know. The square root, a lot of people forget that this means square root of x, x to the 1/2 power. Do you remember what the square root graph parent is? Like that. Okay? Then take a guess before you try it on your calculator. Take a guess at what x to the 1/3 is going to look like. Don't say it. Don't say it, but then try it on your calculator, and if you're going to do it, go x power of parentheses 1/3, otherwise it won't do what you think it'll do. Did it go something like that? All right. What do you think x to the 1/5 would look like? Like that. How about x to the 1/7? Pretty much like that. How about x to the 1/4? Pretty much like this one, x to the 1/4 to the 1/4. Sorry, not equals. X to the 1/4 look kind of like the x to the 1/2. All right, last thing I'll let you summarize it for yourself. The last thing I want to, oh, you have a question, go ahead. All the even ones, yes, the square roots like that start at 0. And if you think about it, they're square roots. And so if they're square roots, why can't they have negatives in them? Because they're square roots, and you can't have negatives in them. And the odd ones are cube roots, and can you do the cube root of a negative? You can, and that's why there's this part of the graph. It's there because you can do a cube root. Cube root of 8 was fine. Cube root of -8 is still fine. It's just a negative answer. But when you try to put a negative into a square root, you get big problems. A sinkhole opens up, and you get transported to the nether worlds. Or you could just say it's undefined. Okay. All right, right now, I want you to see if you can hang with the first couple problems on this worksheet with me. I'm going to hand it out right now. Those graphing calcs are also going to be handy when you're doing the quadratic regressions like we did the other day. All right, late night movie people, try to focus. I want to see it too. I've already got tickets bought for Saturday for my daughters and myself and some of their friends. So we're going to. Cool. You liked it? I thought there was some theater that was like doing a 9:30 showing. That shouldn't have been that bad. Oh, they were sold out. Okay, I got you. All right, so let's do this 2.2, number 2, starting with problem number, well, it doesn't even have a 1 on there. It has an A. Okay, oops. Number 1, number A, I guess. F of x is equal to 2x to the 4th. Shh, please be quiet. I know you're whatever, hyper/tired/overtired, but focus. Don't interrupt my lesson here. Almost done. That's number 1, A. And it says state the power and constant of variation. Look close. Can you tell for sure that the x is the variable? Okay, well, there was only one variable, so it wasn't too hard. But if there'd been like a z in there, it'd have been hard for you to tell maybe. But look here, and it tells you that x must be the variable. Okay, so then what's the 2 called? 2 is the constant, and what's the 4 then? The power. All right, good enough. And then it says, wait a minute, state its domain and range. I have to use math? What is this? Domain and range. Okay, well, if you know what the graph looks like, you remember me talking about x to the 4th and now they all kind of look the same as x squared? You remember that? If the graph looks like this, can't you tell me its domain and range really easy just by looking at the graph? All right. Another way to say it is algebraically. Do you get how nothing could crash this function? And therefore, domain is all reals? Otherwise, I could have just looked at the graph and said domain's all reals. Otherwise, how about the range, though? The range, you really need a picture. And on the range, I'm going to say from 0 to what? Infinity. And even if I stretch that thing, it's still 0 to infinity, right? All right, yes, it says in the directions, take the domain and range. Okay, the power just went out. I'm going to pause for a moment. Okay, so that was a fairly easy one. I think 1, 2, 3, and 4 all should be easy. If you can just sketch the picture, you'll be able to know the domain and range, and it'll be really easy. Okay, let's move on to, let's say, number 5. Number 5, it says f of x is 2/3 x to the 4th. To the 4th. I didn't need those parentheses, but it doesn't hurt anything. Now it says describe the transformations in the correct order. All right? This is kind of like the parent. You know what it kind of looks like, right? Kind of looks like a U shape, kind of like a squared would. Then the only transformation is that one thing, the 2/3. What is the transformation? It's a vertical shrink factor. That's it. And there's only one thing, so in order makes it kind of like, yeah, there's only one thing, so what's the point? All right, so all of those are as easy as you probably think they are. Let's move on to number 11. Number 11 is asking you to pick out which of those curves in the picture would be f of x equals negative 2/3 x, and then that's to the 4th. All right. Do you know generally what that kind of looks like? Generally like this, except then what happens to it? You flip it. Just wait. You flip it. And then, what would that 2/3 do it? Make it wider or narrower? Okay, so would you agree that generally it should look like that? Then which of those pictures, since they're only graphing quadrants 1 and 4, I don't need this part, right? So now, from there, you figure out which one looks the most like it. Yeah, it's not a straight line like F, right? So it has to be G. Okay? All right, I think you got the idea there. Let's flip to the back side. There's lots of problems only because these last few seem like they're really long, but they are just find the cubic regression. Wait a minute, cubic regression? That's a lot like, what's the last one we did? Quadratic. It's just instead of quad reg, now you're going to do what? Cube reg, and it's the same exact process. Just be careful. We'll always tell you, we're not going to make you try to figure out whether it should be linear, or quadratic, or cubic. We'll tell you. We said in this one that it is cubic. So you put the data in. Those years, of course, are under X. So the top row there, 1960, 1970, 1980, that's your L1. Are you getting that? Because you normally have your data listed for you the long way. This is listing it across. So if you're putting in the data 1960 and 12.4, I hope you can tell that that's going to be the L1, otherwise known as the X. And this is going to be the L2, otherwise known as the Y. Times are always X. All right. And then, wait a minute, number 18, power regression. Grab your calculator. Hit the stat button. Go to calculate. Arrow down. Do you see linreg? And then what's next? Quad. What's next? Cubic. And then what's next is called quartic. And that's if it's x to the 4th, but we haven't done that one. Keep going. What's after quart? Linreg. We don't want that. What's next? ln was ln. That means log regression. ln means natural log regression. Keep going. Power reg. PWR-REG. Power regression. It says PWR. See it? Power reg. Just arrow all the way down a bunch of times. You'll see PWR-REG. That is a power regression. So I'll let you see what that's like. All right, and there is one review problem, and it is, of course, important because you have these cumulative tests that come along. And if you don't keep reviewing the old stuff, you will forget it. And then those cumulative tests, which have the power to not only count as a test, but can also be a retake, and are so important, you will bomb them if you don't keep doing these review problems. So please, if you're going to skip a problem, don't skip number 20. Skip something else. All right. Now we have, about 10, 12 minutes. I know you'd rather just goof around, but there's your choice. There's now you and there's later you. Always be nice to later you. It's your choice, though. I can't stop you. It's a Friday. If you want to just sit there and wish that you were drinking a coffee from Caribou or something, you can do that.